Prime numbers are numbers that only divide by themselves and 1. They don't have any other factors. So 7 is a prime number because its only factors are 1 and 7. Here's a list of the first few prime numbers. Try and learn these if you can. It'll make your life a lot easier if you do. You can pause the video if you want to copy them down. Here are some prime number facts for you. 2 is the only even prime number. Apart from 2 and 5, all prime numbers end in 1, 3, 7 or 9. However, not all numbers that end in 1, 3, 7 or 9 are primes. For example, 27 ends in 7, but it isn't a prime as it divides by 3 and 9 as well as 1 and 27. And 1 itself is not a prime number. Okay, you need to be able to identify prime numbers. So say you're asked, is 21 a prime number? Well, it's odd and it ends in 1, so it's looking good so far, but 21's in the 3 times table. It's 3 times 7, so it's not a prime number. Okay, another example now. This time you've got a whole list of numbers and you need to circle the primes. We can start off by getting rid of all the even numbers because we know that 2 is the only even prime number. Okay, now we can get rid of the numbers that end in 5. So we're just left with 3, and we'll look at these one at a time. 11 doesn't appear in any of the times tables, except as 1 times 11, so it's a prime, so we'll put a ring round it. 29 doesn't appear in any of the times tables either, so it's also a prime. But 33 comes up in the 3 times table, as it's 3 times 11, so it's not a prime. Okay, we'll move on to another example now. This one's just like the last one, but the numbers are a bit harder. So again, we'll start off by getting rid of all the even numbers, and then all the ones that end in 5. Okay, for the ones that are left, we'll try them one at a time. There's a little trick you can use to test a suspected prime number. If it ends in 1, 3, 7 or 9 and it's less than 120, you can try dividing it by 3 and dividing it by 7. If neither of these gives you a whole number answer, then it's a prime. So we'll try 97 divided by 3. Well, that's 32.333. It's not a whole number. And 97 divided by 7 doesn't give you a whole number either, so 97's a prime, and we'll put a ring round it. Okay, we'll try the same thing for 39. 39 divided by 3 is 13. 13 is a whole number, so 39 isn't a prime. Okay, on to 53 now. 53 divided by 3 doesn't give you a whole number. 53 divided by 7 doesn't give you a whole number either, so 53 is a prime. Now on to 77. 77 divided by 3 isn't a whole number, but 77 divided by 7 gives you 11, which is a whole number, so 77 isn't prime. Make sure you're happy with what prime numbers are, because you're going to need them in this next bit. Prime factors are the factors of a number that are prime. So 3 and 6 are both factors of 12, but only 3 is a prime factor because 6 isn't a prime number. Now, here's a really important fact. Any number can be written as the product of prime factors. Yep, any number at all. What this means is that you can break a number down so it's made up of multiplying a load of prime numbers together. So you could write 12 as 2 times 2 times 3, and 2 and 3 are both primes. You can see that you can repeat prime numbers, so you've got 2 2's in this example. For bigger numbers, you can use a nice little method called the factor tree to break a number down. Here's how you do it. If you wanted to write 54 as a product of its prime factors, you start off with 54, and you break it down into 2 numbers that multiply together to give you 54. So I've chosen 6 and 9. Now, neither 6 nor 9 are prime numbers, so you need to break them down as well. So you can break 6 down into 2 times 3. Both 2 and 3 are prime, so you put a ring round them. And you can break 9 down into 3 times 3. And as 3 is a prime, you can put a ring round those. You can stop when all the factors are prime factors, and it's a good idea to put a ring round them so that you can keep track of them. So you can write out 54 as 2 times 3 times 3 times 3. Or if you wanted to put it in index notation, that would be 2 times 3 cubed. You've just combined all the 3's into one term to make it easier to write down. You could have worked out your factor tree in a slightly different way, like this, but you'd still end up with the same answer. Okay, here's another example. You want to write 84 as a product of its prime factors. If you want to have a go at this yourself, you can pause the video, do it on your own, and then watch the video back to check you did it right. Okay, we'll start by writing down 84, and then break it up into two numbers that multiply together to give 84. So I've chosen 7 and 12. 7 is a prime number, so I put a ring round it. 12 isn't a prime, so I need to break that down. So I'll write it as 4 times 3. 3 is a prime, so I put a ring round it, but 4 isn't. I can break 4 down into 2 times 2, and 2 is a prime, so I'll put a ring round those as well. Which means that you can write 84 as 2 times 2 times 3 times 7, or in index notation, that's 2 squared times 3 times 7. Even if you did your factor tree differently, you should still end up with the same answer. In case you need a quick reminder, here's a summary of the key facts. Prime numbers are numbers that only divide by themselves and 1. They don't have any other factors. And prime factors are all the factors of a number that are prime, and you can write any number as a product of prime factors. Make sure you know how to find prime numbers and prime factors as well.